All right, the last homework assignment for our class, the law of cosines homework. I think you'll find this homework isn't necessarily easy, but it's a little bit easier than the law of sines homework because we don't have this ambiguous case to worry about with the law of cosines. This first question, much like the first question in the 8.1 homework, just asks you for the area. Remember, we came up with a new formula for the area. It's called Heron's formula. That's in the first video that I made in this section. It tells you that if you have the three side lengths in a triangle, you can figure out the area of that triangle. So this should just be a matter of plugging numbers into a formula, getting the area of that triangle, moving on. Question 2, they give you two side lengths and an angle, but note that angle is the included angle. So when you have two side lengths and the angle is not included, you can use the law of sines. But when you have two side lengths and the angle is included, you can't use the law of sines. You have to use the law of cosines. We want to solve for this side length. So my advice to you is label the angles however you want. Call this capital A, capital B, capital C, that's fine. But if you call this capital A, then this has to be little a. And you want to grab the version of your law of cosines formula that involves a capital A and then plug in little b and little c and solve for little a. If you leave your answer as an expression, you might have the cosine of 48 degrees as part of that expression. Make sure you type it in as the cosine of 48 pi over 180. If you don't want to leave your answer as an expression, you can also use a calculator, just round it to 4 decimal places. Question 3 is kind of the same idea, except instead of having you use the law of cosines to solve for a side length like you do in question 2, in question 3, you use the law of cosines to solve for an angle measure. But that's no big deal. They're calling this capital A, so just make sure you call this little a, and then these can be little b and little c. It doesn't matter which. Grab the version of the law of cosines formula that has a capital A in it, solve that for the cosine of A, and then the arc cosine of that big mess will be your answer. 2 comments here. First comment, there is no ambiguous case with the law of cosines. You don't have to worry about that at all. Your answer is just the arc cosine of whatever you decide it's equal to when you solve this thing algebraically. Second comment, be careful. They want your answer in degrees. If you leave arc cosine in here, that's going to be giving you your answer in radians. So make sure you multiply it by 180 and divide it by pi to get it into degrees. Your other option, as always, is to just use a calculator and round to 1 decimal place, apparently. Question 2 and 3 are the types that you would see if this were a test. However, I would choose this not to be 48 degrees, but instead, I don't know, maybe 45 degrees or something. And I would choose these numbers very carefully so that when you got the cosine of A equals something, that something would be, I don't know, 1/2 or root 3 over 2 or root 2 over 2. I would make these be values off your unit circle, but much like you see in questions 2 and 3, it would just be a one-step process. You wouldn't have to figure out your answers and then use those to solve for other angle measures or side lengths of a triangle. That's not something I will test you on. However, that is something you do in the next couple questions here. In question 4, they give you all 3 side lengths and ask you for the different angles here. Okay, this is a little bit annoying. They're using Greek letters instead of capital letters. This alpha here is just capital A, this beta here is capital B, and this gamma here is capital C. You got some options in terms of how you do this. To figure out the first one, I think you'll have to use the law of cosines. Again, same comments about being careful. They want your answer in degrees, so make sure you're careful with your units. Once you figure out one of the angles, you can either use the law of sines or the law of cosines to figure out the second one. I'd probably recommend using the law of cosines. I think it's a little bit easier. I don't like the law of sines. That ambiguous case just makes things hard, but it's up to you. You can use either rule to come up with this second one. For the third one, you got lots of options, but the easiest option is just say the sum of all 3 of these is 180 degrees. So my answer here is 180 degrees minus whatever my answer here was, minus whatever my answer here was. If you're leaving your answers as expressions, just like copy and paste those things. If you're figuring these out rounded to 2 decimal places with the calculator, then fine, use your calculator. Solve for these 3 angle measures and you're all done. Question 5 is kind of the same idea where you have to solve a triangle, except you're not solving a triangle when you're given all 3 side lengths. You're solving a triangle when you're given 2 side lengths and the angle in between those 2. However, this is custom made for the law of cosines. Again, they use the alpha, beta, gamma thing, which is annoying. This is capital A up here. This is capital B here, and this is capital C here. I think what you'll want to do is first use the law of cosines to solve for capital B. Then you'll have 2 angle measures, capital A and capital B, so you can get capital C for free. And now that you have all the angles and 2 of the sides, you have your choice on how you figure out the last side. You can use the law of sines or the law of cosines, whichever you prefer. Same comments over and over again. These answers should be in degrees, so be really careful with your units if you're typing your answers in as expressions. Then we get into the word problem section, which sounds horrible, but I promise you it's not that bad. It's not really even a word problem, right? They're drawing the triangle for you and labeling stuff. They're giving you 2 side lengths and the included angle and asking you for another side length. Question 6 might as well be question 2, right? It's the exact same thing. It's just in the context of a lake and the distance across a lake or something. Fine, whatever. Figure out 6 just like you did 2 and you should be done with it. And then 7 is extra credit. They don't actually draw the triangle for you, but maybe you can read through this and see what's going on. The reason I made this one extra credit is because it's a little bit tricky. They don't tell you the side lengths. So we got a pilot flying in a straight path for 1 hour and 30 minutes. But you know that the speed that pilot is going is 610 miles an hour. So if you're going 1.5 hours at a speed of 610 miles an hour, maybe you can multiply 1.5 times 610 to figure out how many miles this pilot was going in that direction. And then you turn 10 degrees to the right. So sort of picture a straight line that just sort of barely veers off to the right here. So I have a line going this way and then a line that just slightly turns to the right. And what I will want to end up figuring out is the length of the third side in that triangle. So another trick to this problem is this 10 degrees will not end up being an interior angle in your triangle. I think 170 degrees might end up being the interior angle that corresponds with this 10 degrees in your triangle. If that makes any sense, great. I think when you start drawing this picture, you'll be able to figure it out. But the good news is you don't have to if you don't want to, because this is the extra credit question on this assignment. So you can just skip it if you're sick of this stuff and sick of homework in this class.